So welcome again, everybody. The next talk is from Alan Franzoni, who's a Python developer and a friend, and he's always complaining about system architecture and design, all these things, very annoying to everybody, and now he's going to be annoying to you. So let's give a hand.
Thank you, everybody. So, I think we need a bit of context on this. What happened to me some years ago is that I was working in a mixed Python and Java shop, and some developers were really happy when I told them that I was taking over their Python work and doing it myself. And they were perfectly happy to go back to doing full-time Java work. And I could not understand this. Then, in a couple of years, after having done a lot of Python development and a lot of release engineering as well, I came to know what they meant. They were, and they are still, skilled developers, skilled engineers, and they just seen at the beginning some of the shortcomings of the Python as a platform that I could not see at the beginning. Those shortcomings are not really something that doesn't work. More a kind of design decision that occurs in the Python platform. So, my original idea for this talk was why Python sucks. There was an old talk at a Django conference which then sprung a lot of speaking in the Django community. But what I really wanted to say was, it's not that Python sucks. This can apply to any platforms. So, you start using something for your project. Do you know what are the trade-offs of your choices? Do you know why you should use Python in a certain context? Because we are here and you can find plenty of talks telling you why you should use Python. Do you know why you should not use Python? So this talk is highly opinionated, it's full of factoids, and I suspect that some of you will simply not agree with me. So I just ask you to not agree with me at the end of the talk. So keep your questions for the end, and you can just tell me that I'm dumb I don't get Python. Okay? So let's start. What's your aim when developing a software? Should you enjoy it? You probably should, but I suspect it's not your main topic, your main goal. Should your software be fast? Beyond defining fast, that depends. There might be softwares that have to be really fast, that must run in no time, or they must perform a lot of analysis, and so on. But most probably, if you're doing some kind of web development and using Python as a main language, your main focus is development productivity. So, you care about the software total ownership costs. It is the total cost of delivering the software to your customer and maintaining it working. Okay, so that's the focus. I'm not saying in my talk that something can't be done in Python. You can do everything. What I'm saying, when I'm talking about this, is how much time does it take for you to do this in Python as a whole? So the main topics are language itself, code reuse, tools, and deployments. What about the language? Do you like Python? Yeah, I think that the language is pretty good. It's clear. It allows you to express all the concepts you want in quite a concise way. But let's see, for example, what I consider to be trade-offs of the language. It is dynamically typed. So I won't speak about testing and methods that don't exist. There is one point of dynamic typing, well, at least two, but the other one I will tell you later, that really bothers me. So you work in a team. Maybe it's 10 people, maybe it's 20 people. I have worked in teams when doing Java, which could be something like 25 people. You must tell other people beyond you what your methods expect, what your classes want when you instantiate them. So, in Java, this is pretty easy, isn't it? Even without any kind of documentation, the code, if properly written, is kind of self-documenting. Type arguments, just tell anyone what should you use as an argument. You may say, yes, but we can do the same in Python. We can just add the documentation to our methods. This is an example in Python of doing such a thing. What are the problems here? First problem, if you count the length of both files, surprise, the Python version is longer than the Java one if you need to document everything. If you don't, can you remember after a year what's an argument supposed to be like? Can you remember what's the return type supposed to be like without peeking at the code? So what you should remember when using dynamic typing is that you are actually removing information. You are saying, okay, I don't need it, I don't want to use it. But it's not an advantage. It's a trade-off. It may be quicker to write dynamically typed code, but you may lose information when using it. For example, if you're using an IDE, it's very hard for the IDE to properly pick the auto-completion, the call tips. You need to pick between the documentation code and the actual code you're writing. It's not a matter of typing. Have you ever seen this? No? It's quite famous in the some kind of word. So the idea is that typing, okay, sorry. Typing is not a bottleneck. So many people think that Python is quicker to write because you need to write less chars. But it's not a real problem. If you take a look at how much time do you spend when during development, most probably you are going to spend a lot of time in designing, in thinking, in speaking with your partners about methods, and so on. It's not really a problem. Yes, if you write in Java, the problem is that you go a lot more, you spend a lot more time in reading your code because it's stuttering, you know. It's really slow, it's really not powerful. So the real problem with Java, for example, which I use as a comparison because it's a platform I'm quite proficient in, not because it's the best platform around, okay, is that it tries to give you an armor. An armor removes power from you and protects the programmer from itself. That's the idea beyond Java. I think that many people think that Python is quite a protective language because it's simple, because it's easy to learn at the beginning. I think it's not. I think that Python is quite a powerful language that you can use to do any sort of things, but you must know what to do. Otherwise, when working in a team, you risk that something doesn't work. Not because you wanted to work it this way, but because something happened accidentally. And a good example of this is sys.path. What is sys.path? It's the way Python uses to understand what's the path from which to import modules when you do an import something, right? What's the problem with sys.path? Your opinion? No idea. In my opinion, the problem is that it's mutable. If you take a look at a lot of Python programs, especially those that were written by not really experienced programmers, you can see they do a lot of things with sys.path. While this may not be a problem, sometimes you end up with your whole program not working because the sys.path was messed up in some strange ways. The opposite, the total opposite, is class path. I think there's a PAP in Python now calling for a different way of loading packages. But the Java class path is set at the beginning, and you cannot modify it at runtime unless you hook into the class loader mechanism, which has a very definite way of hooking into it and of altering the way classes are loaded. So the trade-off in this situation is that you're trading power and freedom for a recognized and shared way of doing something. So as long as you're working alone, as an example, this may not be a problem. You know what you're doing, your code works, and you perfectly know what it is supposed to do. Let's suppose you're working in a large team, and everybody starts altering the sys.path without a precise plan. You can just end up with something that doesn't work, and you don't understand why. When you've got a path problem, it's usually tricky to find out what's happening, because a different module may be imported in place of the one you wanted to, and so on. So I think there's not news. So the whole idea of the trade-off between power and safety is a long history of programming languages, libraries, frameworks. You know, every time somebody springs out with a new language and says, oh, this is more powerful, oh, this is less powerful, oh, this is something in the middle. So nothing new, just be sure you know what you're doing. And another problem, code reuse. I think code reuse is one of the central issues or the central trade-offs when you are working with Python. What about the standard lib? It's good, it contains a lot of useful things, and it gives you quick and full access to the underlying OS API. But this may limit portability. So you must be aware that whenever you're using the standard lib, you're actually accessing a lot of the internals of your operating system. Behavior may vary even across similar operating system. So different Linuxes, different versions of the same Linux can produce different results. Also, sometimes the standard library is a compile time choice. So different distributions can ship different versions of enabled modules. And what about code reuse for C libraries? You usually get EuroPython, an extension which wraps a C library. Great, you reuse existing code. You don't have to code it again like in Java. In Java, everything is coded again. But the behavior may vary. It happened to me once. I was using the LXML library on Red Hat 5, 32-bit. It worked flawlessly. One day, we had to switch to 64 bits. And suddenly, one precise function in the LXML library, which links to GNOME libxml2, stopped putting the content in XML tags. So you had just empty tags. We looked for everything we could look. The platform stayed the same. It was probably a 64-bit bug, you know, something we could not tell, and then we coded another function through the same. But deployment behavior may vary. So if you want, don't think you are fully cross-platform. And my other word is a personal rant, if you can take it, is packaging. How do you package a library for reuse in Python? Did anybody of you ever create a package, a module, submit it? Oh, it's not important. But I think there are many, okay, no.
Yes,
Distributors, or setup tools, or distribute, or maybe distributors too. Do you like distributors too? Or maybe you prefer to use PAP.
Actually, I use PIP with any of the previous. So.
Okay, let's see a rookie entering this room and asking you, how do you package a module for Python? Oh, there are plenty of ways of doing it. Everyone is different. Everyone is slightly different from the other. And not any of those are really compatible with the others. So it may happen, it has happened to me, that something worked with setup tools, not with distribute. Distributors 2 is still in alpha stage. It will be the next big thing, but it's not designed to be backwards compatible with all the other tools. PAP is a third-party module. I think it works fine, but it's got a different way, for example, of specifying dependencies. So what? You just want to know one way to do it, and you don't know which is the proper way to do it. There are some other issues with those tools that I will discuss later. But the second part is, isolation. So if you just use those modules, you just end up with all your things in your site packages directory. So what you do, what you usually do, you take a software, a third-party software, which allows you to isolate your environment. I know Build Out and VirtualEnv. They are both good tools. They have a different approach, and each of them has got its sets of problems. So for example, Build Out, in my opinion, is quite hard to start working with. Whenever you get an error, it's very cryptic, and you don't understand what's your problem with it. But it's got a nice declarative approach, and it allows you to solve dependency diamonds. We'll see that later. VirtualEnv seems to be the preferred solution for many people, but it's kind of stateful. So you start an environment, you install dependencies, you make modifications. If tomorrow you need to reproduce the very same environment, it may not be so easy. There are some tools which allow you to. But if you need something beyond the basic packages, which you can find in the setup file, it may be hard. So, what's the problem with the diamond dependency? Maybe this is very common in the Java world. I don't think it's so common in the Python world. So your project is A, it depends on B and C depend on two different versions of D. If you just try to solve this with setup tools, you'll end up with an error. It will just tell you, I cannot satisfy dependencies for X, and you are done. No solution. If you use Build Out, there is a solution. It allows you to work with different dependencies. So the problem with all those tools in the Python world about code reuse, it's not any of those tools. I think that all of those tools are good, and all of those tools are very good if they are used as intended, but first, they don't play together. Each tool is a different implementation, and you must be able to cope with all the possible different version or different interpretation of these tools that the author had. And if you talk about packaging, there are some more issues. For example, when things are done in setup PI file, for example, people import a module before using it, before installing it. Or some package works with distribute, others work setup tools. There are dependency or version conflicts. For example, you may find that a dependency does not exist anymore because the Python package index is mutable. So you can remove dependencies from it, and you can re-upload the dependency, a different dependency with the same version number. So we will just pick the wrong tool, the wrong software from the package index. And now I have a FACTOID. I have tried it on this very machine some days before getting here. So you just get a machine. You try installing something with easy install from the package index, straight out the package index. Okay? You suppose you have all the libraries and the headers you need on your machine. You try installing a software and see it work. I have seen on a kind of 20 packages I randomly chosen that 1/3 of the packages on the package index don't work out of the box. Either because they were missing a dependency in the setup file. So somebody developed it, they had a dependency in the site packages, they just forgot to put it in the setup file, and when you upload it on the package index, the package doesn't work. Or they were trying to import a module before installing it, and the module may have another import on another dependency, and you could not use it. Or sometimes they do install, but then they do not work because of a missing dependency. You import it, it doesn't work. So another factoid is I once worked in a Java project with 50 or 60 dependencies. We had to fork one of the software we were using because of the subtle bug. In a Python project I worked with, and for what I was the release manager, I had 10 dependencies, and I had to fork 5 libraries, not because of bugs, But because of setup problems, because of dependency issues, and things like those, it was impossible otherwise to keep the project working. I started it one day, then the next day, without doing any change, the project would not work anymore. This involved creating a mirror of the Python package index, an internal mirror, to be sure that the dependencies of the upstream project did not change in an unexpected way. Many people in the Python community just use the dependency name, just the name of a package, as a dependency in the setup files. This is an issue because if the upstream dependency changes and compatibility is broken, you end up with a not working project even though you did not change one single line of your code. And this way of using dependencies is considered a best practice. At least I have been told in mailing list that it's a best practice not to specify the version number, and at the same time they say, yes, but you should not break compatibility. But this happens all the time. This happens all the time. I want to make a comparison with Maven. If you don't know Java, Maven is the do-it-all dependency and the deployment tool. It's a nightmare. It's XML-based and its configuration is terrible, so if you start with it, you are just driving crazy. That's right. But it's declarative, so you basically get the very same build on all machines and all the time. All dependencies are very clearly specified. All the Maven repos are usually immutable. So if you compile something today and you compile sometime in a year, you will get the same build every time, everywhere. And there are some very good proxy and caching repositories available. Those tools I could find in Python are a bit hard to use in a lot of time. In my opinion, this is a matter of authority in the sense that Python core developers are not concerned with many tools as they are not connected to the language. I think they are right. I mean, they don't care for a lot of things that are around the core Python. But they are needed whatsoever, and there is no third-party authority in Python like Apache or Eclipse. You may not like Apache, you may not like Eclipse. The most similar thing to Apache or Eclipse in the Python community is Zope, but I think a lot of people in the Python community does not like Zope on Zope products. I think that many people say, oh, no, I just don't want to hear from them. Never, never. So we've got few shared practices and few shared APIs. Everybody is making his own implementation. For example, setup tools. The so widely used setup tools, as many of you will know, was created by a skilled programmer, Philip ABI, I think. But one of the problems was that he was working mostly alone. There were very few committers, and at the moment, when other people could not gain access to the code base, and he had not more time to go forward with the project, setup tools got stuck and had to be forked. In a community project like Apache or Eclipse, this is less likely to happen because there is a team beyond the solution, beyond the software. But the reason because code reuse is really important is that if somebody else has written something in Java and spent 10 years in developing it, and they can just pull it down, use it, and forget it, why should they care if it's Java or not Python? In terms of development productivity, this may be higher. If I spend 10 days in deploying something or in solving dependencies, that time I could have used to just develop something different in my software. So that's the point of development productivity. All of those issues have solutions in Python. You can fork everything and do whatever you like, but it may be costly. So I think that not invented here syndrome is quite widespread in the Python community. So everyone tries to bake his own solution before trying to do something that can work with other solutions. Before creating a sort of API we can use and reuse. And I think the code reuse in Java, for example, is much easier. So the trade-off I want to say about is, it may be quicker and more fun to write in Python, but reusing others' works and maybe your own works in your own company may be harder. For example, can you tell me how many whiskey middlewares are around encapsulating the request and response objects, something like that? I think I have seen Django, Flask, Webob, Paste, Warthog, that's 5. And most of them share a common core functionality, so they serve to the very same purpose. They are different implementation, and there is no common interface on them, not even for the basic functions. So you don't have an API and different implementation which can let you to focus most on a certain task. What about tools? Tools, in my opinion, matter. I'm not a VI or Emacs fan, and I think that an IDE provides you with more productivity. The learning curve is usually better for newcomers. Learning Emacs or VI may be slow. If you're adding people to a team, if your team is growing, if you need to teach VI or Emacs to any newcomer, you will just slow down your productivity. Code completion can help you a lot. A lot of people say that code completion is not really useful. I think it is, because you don't have to pick between documentation and code. You just stay focused on the code, you do completions, and a good debugger can help you a lot in a lot of situations. I think this is mixed feeling with Python, because everybody's got a kind of slightly different debugger, but they usually work in the latest years. And refactoring matters. Usually you start with one version of your application, then you refactor. This is agile. Refactoring in Python is harder because of the tools and because of the language. If you change a method name, it may not be changed in the whole chain of the methods that use it. So it takes you more time to refactor. What you do? You spend more time refactoring, or you don't refactor. Neither of the solution is optimal. And as I said before, Python tool means integration. There is no one way to do it. I was once in the JetBrains forum when they were developing PyCharm, which I think is the best Python IDE so far. And sometimes the JetBrains developers were just asking things like, but how should we do it? So different people were telling them different uses of the same tools. I do this, I usually use virtualenv this way, build out and set up it this way, and the developers were just saying, we don't know, we are picking one way and just use it. We cannot know, there is no way that it's written, you should do that, or the preferred way of doing that is this setup. Other ideas use their own build files, so you can't reuse their test project and setup project with continuous integration servers. Debugger integration may work or may not work. So that's the opposite of the Java world. Java being a strange language, but the tools work together. They are highly integrated. They share APIs. If you've got a Maven-based project with a POM, you can just check it out, build it, and start hacking. Stop. You don't need anything else. So it's very fast to pick up on an existing project and start hacking. This is very common for large-scale software like the so-called enterprise software. We've got a lot of people around, a lot of turnover. You may not like it. It may not be your focus, so you don't care. That's perfectly right. But there is a use case for things like Java. There are a lot of use cases. And I think that Ruby works far better than Python as well, even though it's as an infrastructure. I have mixed feelings towards the language. But I think that the gem system, for example, works quite fine. And my last point is continuous integration and delivery. As a release engineer, I was burdened with the task of creating a self-contained RPM to install on Red Hat machines. This RPM had to contain a fully isolated Python program. So all the dependencies, because different projects on the same machine needed to work with different dependencies, and almost standalone, so nothing else. So the system Python should not have anything but the standard library. It was terrible, and I had to basically bake my own solution. I have seen other people at this conference baking their own solution for deployment and delivery. So I suppose this is quite a common issue for Python developers. They need to put their own software on a lot of machines. For delivery, I think the deployment, for example, for a web app, but even for a standalone app, are highly manual in Python. So you just need to tinker a lot on the server. You have this whiskey descriptor where you've got to set paths and so on. There is no standard way of doing it. You just have code, executable Python code, and you have to let it working. About the RPM packaging, I already said. And if you make a comparison with the Java solution, which is the deployment descriptor and the WAR file, that's more a standard way. Just an example, Google App Engine. In Google App Engine, the way to deploy a Python application is to create a YAML, YAML file, which describes the way your paths are mapped to your software. What about the Java version? They are using the deployment descriptor, which is standard Java. In Python, they had to invent something that was basically the same, but it's not an API. So then every kind of framework or application just reinvents the same thing. About continuous integration, you need reproducible builds. You usually want reproducible builds, but it's hard in Python to make an environment stable and deliver the very same artifact from continuous integration to production. A lot of times you will see that installing modules hard code paths, full system paths into modules and things like those. So creating an environment which is very similar from testing to integration to production, and reproducing a build is very hard to do in Python. That's my opinion again. So I'm about to finish. So what I think in the end, what is the good use case? I think that Python works very well, and you should pick it up because it may give you an edge over other people that don't use it. If your team is small, is well-gelled, is experienced, if you have the time to invest on internal standards, so you say, we do this thing this way. If you're dealing with a lot of code, it involves creating your own solutions. So you don't care about anybody else's solution. You just want your solution. Maybe you've got one or two dependencies, and you're done. That's great. If you pick an operating system, a platform, so you've got control of your servers, you choose an operating system, use the same operating system on your development machine and on your servers, then that's great because you can find problems very early in the development process and you don't have surprises when you deploy it. Many times, if you're developing an application for the enterprise world, you don't pick your operating system, and a lot of times you don't have access to your servers. So you just have to give a package to your customer, and they do an unattended install on their servers. This is tricky to do in Python. It may take you a lot of time. So if you've got, for example, a large distributed team, maybe a junior team, that happens. It happens a lot of times. Not everybody is experienced in this world, and people need to have space to grow. If you throw junior people in a large Python project, they might just end up with a mess. So whenever you need a lot of code reuse and things like that, think twice about Python, or at least be prepared to solve some problems that are not solved by the platform. If you're planning to deploy on an infrastructure that you don't know, or you don't have control over your operating system and software, then Python may not be, in my opinion, the right solution. Just forget it and don't do like the coders I told you at the beginning, my colleagues. They were very scared, but they tried to use Python for something that Python is not suited for, in my opinion. A small biography, and that's all.
Okay, so we have just locked the door, so he's not running, and you can ask questions.
Thanks a lot for this talk. It was very interesting. I think you're right. When we pick Python or when we pick anything, there's obviously some trade-offs. Particularly, for example, it's easy dynamic typing. Well, if you have dynamic typing, there's things that you don't have. And if you have static typing, then there's some awesome things that you have and some not so nice things that you have. So I have some comments. For example, you were mentioning that typing is not the bottleneck. So what does it matter if I type a bit more? Also, if you have code completion in Java, then typing is not the bottleneck.
Yes,
yeah.
yes.
So, but that's not the point, I think. I think the point is that brain bandwidth is the bottleneck. So if the code is shorter and it's well written, it says what it means. So what is this code about?
Yes.
All doing this. If you have to type a lot, normally you have some, like, well, this code is about this, but it's also about, yeah, I need to instantiate that class and then do that. And then it's like most of the code is just some preparation for doing the real work, which is a short path. So that's why that's what I like about Python.
I totally agree on you on this. What I think is that switching between documentation, it's not the problem with typing, switching between documentation and coding really makes me lose my focus. In Java, I don't have to do that because code completion lets me to stay on the same window all the time. That's my problem. If you don't suffer this, just be happy.
Well, I use code completion in Python, but also the documentation that you showed, well, it looked a bit Java-ish, like you were really caring, I want this type for this variable. Well, sometimes you do care, I really want this type for this variable, but some other times, and I think in most of projects, you just care about something that will work with you. I need something that has an ID on it, an iterable of something that looks like this. So what I normally write in the documentation is as short as possible, like, this is what I need. Sometimes, yeah, I need to put the whole class path to the type that I need, but
I think I find this a communication problem. I find it's hard in Python to communicate other people what you need. Just an example. Sometimes you say a plural noun and you say, you need some wings, for example. What is wings? It's a list, it's an iterable. It has happened to me that I was once passing an iterable to a method of a third-party library and it worked. Next release, it did not work because even though it did not specify it, the author was thinking in its mind of accepting a list and so using indexing and other list methods. At the beginning, he did not use them. It's a matter of communication. I mean, I think dynamic typing is good, but it's harder to communicate what you want to accept or to return.
Just, sorry, so we can ask questions. Just a comment about this, because I wanted to say to you either. The point is that dynamic Python, dynamic typing should care about behavior, not typing. So if a class or a variable implements a behavior like you want, it doesn't matter if it's iterator or list or so on. But if you really care about type and you want, you can do many things to just like raising errors or things like that.
I don't care about about types, but how do you tell me which behavior do you expect without having me pick throughout the code? That's the only problem. I understand the behavior thing and I accept it, but how do you tell other people in your team what is the expected behavior of the classes that get pulled into methods?
Okay.
Yeah,
we can talk later about this.
Okay,
so we can give space to other questions. Harold had the one before, so sorry.
I think you raise quite some valid points. If you look at Python should be a cathedral. A cathedral. You know the famous thing about the cathedral and the bazaar?
Yes.
Java and Java ecosystem is a cathedral. It's like the Catholic religion. Everything is given by the Pope, what you have to do, what you don't have to do. And you can trust. He knows everything. That's the rule in the Catholic Church. So if you accept it, you can trust on it. In Python, we have a benevolent dictator, but he does not really cut in our daily life. And so everybody does what he thinks is right. And that is a bazaar. And you told us a lot about expectations, that things are organized and you can trust on them. And Python, there is no central authority. And yeah, if you need a central authority, I totally agree, Python is the wrong tool. If you need a central authority to say it, yeah, great, thank you.
I think many people know what I wanted to say in this talk, but I think that some people doesn't know. That's the purpose of this talk. Once you accept it, we are friends.
Now, I have quite a lot of experience with the development both in Java and in Python, and in my experience development time is usually a factor 3 faster in Python compared to Java. In the actual real time that passes. Certainly deployment and things like that are problems which could be better addressed. But you still have to realize that the major part of your project is the development, and that is so much faster that, in my experience, Python wins out all the time.
I don't agree with this, but we have different experiences, so we cannot.
I did a lot of Java too in the last years, and sometimes I agree with your point of view, but really I think that you're biased because you found lots of problems in Python projects, but they are in Java projects as well, probably in any language. I have found Java APIs that are so terrible that Java documentation is just not enough. You just need to call to email the authors because there is no logic at all. And part of it is because how low level you have to think when you design the API, while in Python you have much clearer APIs. Okay, so Maven as well is a very good tool when you do standard stuff. I had lots of troubles with packages with wrong dependencies. If you have to use a non-standard repository, and you end up how you put in your local Maven repository the jars, and so that's basically what you did with PyPy. So perhaps it just really you got you touched the hot the flame. Okay.
Okay. It may be. It may be.
First of all, I want to say I think the PEP process has a certain de facto authority in the Python community. It's not the PDFL alone, but I think this is a specification process, and it's used for standardization. So I think it addresses some of the problems of the talk as well. And my last information about packaging is that they try to PEP this as well right now. The other one is I think it's always a little bit messy to social engineer problems away, and sometimes you have to work more on the ground doing clean conceptual models. So when I saw the dependency diagram, I just didn't see any dependencies, just a directed acyclic graph or something like that. And if you're conceptualize on that level, maybe all the problems on the top are just falling away, and you get into the scientific literature, you get all the results which are proved there. So I think we always should try to find a technical solution, not a social engineering solution. But the PEP process is obviously one, and I think it works quite well.
Okay. Other questions? Okay, so the break has started. If you guys want to go, we can have more questions during the break. Just be aware that you can go.
Alan, just an observation about Maven in Java, because you can, for the dependency management, you can use Maven, EV, OSGI.
Yes, but they are integrated. You can use
Ant, or you can put
Ant
inside.
Ant is a build tool which can use Ivy,
yeah.
but you have got an
How
API.
many times you see in the project personalized dependency management?
Yes, but Ant is the old way to
OSGI
do
is
it.
another one. OSGI for the dependency. There are a lot of tools for.
There are a lot of tools, but there are some main ones which are quite shared, in my opinion. But I told you I was highly opinionated.
So in the meanwhile, let's thank Alan and continue the questions.
Thank you. Ma puoi guarire.